Hello everyone, good evening.
Very good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Okay, so today we have open session for week 11. So before that, how many of you have done gone through week 11 content?
Sir, I have gone through it.
Yes, sir, I've gone through it.
Okay.
So 5 videos.
Yes, sir. I've gone through it.
Okay, so how did you find it difficult? Did you find it able to understand all? What's your review?
Sir, I think Poisson distribution, I need more explanation from you. Like otherwise, others are easy,
Okay.
but the derivation of the formulas and all, I need to really understand that. Or maybe I have to go through those videos again.
Okay. Okay. What about others?
Sir, I found the activity questions according to the, sir, I actually found those tricky. Those questions were tricky, but I have done that, but those were tricky actually. The activity questions after the last lecture. That's my feedback from the last activity.
Okay. Okay. Because I will just share my screen and then we can go lecture by lecture.
So before you start, I have a question. Are you gonna go through topic by topic?
I will go lecture by lecture. Right? This is an open discussion session, so we'll go lecture by lecture.
Okay. Okay, sir.
So coming to week 11. Okay, so first lecture was based on Bernoulli distribution. Were you able to understand the concept of Bernoulli distribution? What is Bernoulli distribution exactly? When do we use it? Or any doubt in this or EQ 11.1? Anyone?
No, sir.
Lecture, no issues, sir, for me.
Okay. All activity question you were able to do of first lecture?
Yeah, first one, yes, sir.
Sir, please explain the last
Yes,
one.
sir.
Last one. Okay, this one,
Yes.
right?
Yeah.
Okay. Okay. So where did you struggle in this question?
Sir, that A. Wait, I cannot see. I'll open in mine.
Okay, is my screen visible to all?
Yes, sir, visible, sir.
Okay.
Sir, I cannot understand the most uncertain, like the value, how to take out. Like the
Okay.
answer is 3. I feel like the 3 is the number 2. Point 2. I'm counting it 3 times, or it's a middle value 3x is equal to like what A is.
Okay, what do you mean by most uncertain trial?
Like 50-50 chances. Equally likely, like the probability of winning and losing is same. It's like not equal. It's equal. That is most uncertain.
And why that's most uncertain?
Because we cannot predict, right? It's 50-50. The probability is 50%.
Okay, but if I have more than 2 of possible outcomes. I have, let's say, 5 possible outcomes in that case.
Then if it is 3, oh, that's why. Okay. Okay.
Okay, so most uncertain means you have a larger variability, right?
Yeah.
Sure. So larger variability, larger the variability, larger will be the uncertainty in your predictions, right? So in statistics, one of the main motive is to minimize the variance as much as you can. Why we do
Okay.
that? Study that in stats too. But most uncertain means maximum variance. So in general, you need to maximize the variance of your random variable y. And what is the variance of Bernoulli trial? It's p
P
times
to P 1 minus P.
p times 1 minus p. So you need to maximize that value, right?
Okay.
And let me just screen.
Sir, but in this one more, hello?
Yeah.
So this answer is coming as 3 points, 2 or 3, sir. Then why we should take it as 3? I mean, any this thing is there in that?
Okay. You need to maximize this value, right? So have you studied how we maximize in stats in maths 1? Are you aware?
No, sir, I'm not doing maths 1 right
Yes,
now.
sir, the first order derivative.
You have to take
What is the
derivative.
first order derivative in that?
Okay. Are you aware of some equation or find minima, maxima?
Yes, sir. Yes,
Yes,
sir.
yes, sir.
Right? So I differentiated this first. Okay. So to find this maximum value, I will first differentiate and put it equal to 0, right? So differentiating with respect to p, I will get 1 minus 2p, right? Putting it equal to 0, I get p is equals to half, right? So it means I'm going to get maximum value when p is equals to half. And we know that my random variable x takes value 1, 2, these 5 values, right? If I'm not wrong, with probability 0.1, 0.2, 0.2, 0.3, and 0.2, right? And I have some random variable y which takes value 1 whenever x is less than equal to a, and 0 whenever x is greater than a, right? So variance of y would be maximum when p is equals to half, right?
Yes, sir.
It would be maximum when probability of y taking the value 1 is 1 by 2, right?
Yes.
And when will y take the value 1? Whenever x is less than a. It means probability of x less than equal to a is 1 by 2, right?
Okay.
So if I plug in at a is equals to 3, I will get probability x less than equal to 3 as 1 by 2, right? So that's why it's
And sir, what will we do for minimum?
for minimum. For minimum also we do the same. Okay, so whenever you get put in, you find this, right? Differentiate plus put it equal to 0, right?
Okay.
And okay, just give me a minute. Okay, so whenever we differentiate, right, and put it equal to 0, so here I got p is equals to 1 by 2, right? What we do is, whatever value we got, we differentiate it again. If I differentiate this value again with respect to p, I will get minus, I'm getting something less than 0, right? So it means the value which I got would maximize. If I got the value greater than 0, it means the value I got would minimize. So in that case, you can check that on differentiating this result again, you are getting negative. So it means that p value would maximize your this argument. So this is something you will study in maths 1.
Okay.
Okay. Is it clear? Any doubt in this one?
Yes, sir.
No, sir. Here, how I did was actually I took the what do you call x e of x. That is 1 into 0.1, 2 into 0.2, 3 into 0.2. Then I found that x is 3.2 or 3 something, sir. I don't know.
Okay.
So then we are saying it is 3 here. So generally we used to in the
No,
previous
whatever you have found is the expected value of x, right? You have computed.
expected value of x.
Here you don't have to compute expected value of x. We need to
In
just
that case, so whatever the probabilities which they are given 0.1, 0.2, 0.3, if we change also a will be equal to 3 only. For example, I put
put it
one
right.
I put 1 as 0.9 and rest as 0.25, I mean 0.025, 0.025, 0.025, 0.025. In that case, how it can be 3, sir?
In that case, it won't be 3, right? In that case, the answer would be a bit different. You need to check on which value are giving you maximum variance. So if you were taking a is equals to 1, what is the variance that you are getting? If you're taking a is equals to 2, what is the variance you are getting? You have to try it out and see where you are getting the maximum variance. So
So
generally,
expected value is not required, only variance is required.
yeah, expected value is not required. So generally what happens is if this is your value of P and this is your variance of that Bernoulli distribution. So it goes from 0 to 1 and with 0.5. So it will go something like this. It will attain the maximum value at 0.5 and then it will start decreasing. So the example which you gave, right? Let's say it's 0.9 for x is equal to 1, right? For x is equal to, meaning it was 0.025, right?
Yes, sir. All others.
0.025. X is equal to x is equal to. So in that case, what would happen is at 0.9 you will have this much of variance, right? When you move forward, your variance will decrease, right?
Yes.
So I think for in that case, at a equals to 1, you will get the maximum variance.
No, that half you did, no, sir. Multiplied by 3, plug in 3, you told, then it will come half. Now, what value we will put there, sir, in that formula? Half only.
In general, what you have to do is you need to maximize this value, right? P times 1 minus P.
Okay, correct. Yes, sir. Yes, sir.
And your P is nothing but probability y equals 1, which is
Okay.
nothing but probability x less than equal to a, right?
Yes, sir.
So in that case, if I put P as 0.9, I will get the maximum value of this variance as compared to 0.925, 0.950, 0.975 or 1.
Okay.
So our main motive is to maximize it.
Okay.
Not 0.5, it could be.
Okay.
Okay.
Okay. My approach was wrong, actually. Okay.
Okay.
Thank you, sir.
Okay. Moving further, independent and identical Bernoulli trials. Okay. So any doubt in lecture 11.2 or activity questions of this?
Yes, sir. I do not understand, sir, these questions.
No, sir.
Which question? We didn't understand.
Sir, I found
I
out.
did not understand that how to approach these all questions, sir. Actually, all questions are interlinked. We have to find every value. I do not understand how to
Okay.
find how to approach this.
How did you approach the first question of this activity?
Yes, sir. That's I face difficulty, sir. I tried, but I do not understand why it is happening so.
The x can take a value from 0 to 5. So n is equal to 5, sir.
Okay. Okay. So here you are given CDF.
Actually, here x is infinite, no, because x is greater than.
Now, from CDF, you have to convert.
It's CDF actually. It's CDF actually.
No, CDF, you have to
Convert PMF.
convert into PMF.
Can you convert CDF to PMF?
Yeah.
You know how
Yes,
to do
sir.
it.
Yes, sir. 1024 will be the first for 0.
Okay.
Then from the second one, you have to subtract 1024, you will get 1280
Hmm.
by
Yes, sir.
3125. That will be the probability.
So like stepwise,
Similar same way, 640, 20,
yeah,
and 1 by
stepwise subtraction.
3125. I found out, sir. All probabilities for all.
But sir, I think we don't need to do all those things. We just need the probability, I mean, for zero only, and then we can find the values easily.
Okay, yeah, we can do that also, but yeah, before that, how to find the value of, and someone is saying that x can take value up to infinity. So for CDF, yeah, we show it that up to infinity it will remain one, right? But you have to convert it into PMF and see what all possible values your variable can take. So if you convert this
But
to
sir,
PMF, you will find out it's n equals 5 in that case.
if it is CDF, sir, then X, Y, it is it is actually probability, no, sir. It should not be. It should be only less than one. No, why it is there is range 1 to 2 only. Means 0 cannot be.
Okay, so for that,
2 to
go through this,
3. So 1 cannot be.
go through lecture 9.6 again, right? I think you haven't gone through the content properly. Go through lecture 9.6, go through activity 9.6 again, and then come back to it and try again. That week 9.
Okay, sir.
Okay, anyone, anything else?
Sir, here the NP is equal to expectation of X. No, sir, that formula I've used to find the value of P. Otherwise, how we have to approach, sir? My answer was wrong.
Okay, NP equals expected value of X. Okay, how
1 minus
expected value of X?
Expected value of X I calculated by calculating all the individual probability in X takes Xi 1, 2, 3, 4, 5. I have calculated.
We
Then-
can use this approach, right? For P of X equal to 0, we just got 1024 by 3125, right? So that is P of X equal to 0 formula
Yeah.
is NC 0 into P power 0 into 1 minus P whole power n, right?
into 1 minus p to the power n.
Yeah.
That one.
P power 0 into 1 minus P whole to the power of 5 will be this one. So from that we can calculate.
Will be the first one, yeah.
Okay, so you in beginning you have converted the CDF to PMF, right?
Correct, sir.
Okay, so now generally the main trick is to focus only on this x equal to 0 value or x equal to 5 value.
Okay.
Why so? Because if you recall, binomial distribution x is equals to 0 means NC0 p raised to the
The
power
power of 0,
1
1
minus,
minus P to the power of n. Yes.
yeah, that's n. Yeah. So NC0 is 1, right? P raised to the power 0 is also 1. And 1 minus p raised to the power n. Here our n is equals to 5, right? And you know this value.
Okay.
So that, I don't recall what's this value. Let me just check. Okay, so at 1024.
1024.
So
It's 1024 by 3125.
by 3125 is equals to p raised to the 1 minus p raised to the power 5, right? So now you can easily find out 1 minus p from here, right?
Yes. Correct, sir.
Another easy way to, you can use this value. What will happen if we use this value?
1 by 3125.
So it would be, our n is 5, right? I'll just use 5
5C5.
p raised to the power 5, 1 minus p raised to the power 0, right?
Yes, sir.
5C5 is 1. 1 minus p raised to the power 0 is also 1, right? You are left with only p raised to the power 5, which is nothing but 1 over 3125, right?
Yes, sir.
So you can find p again here easily, right?
Okay.
Okay, so that's how you can find it out instead of computing expected value.
Okay, so that is correct, sir. This is the easiest way and correct way. But whether by finding the expected value, can we go through that? That will give a wrong answer, or how is that, sir?
That will also give the correct answer. Of x equals np, right? So if you go by that approach, it would also give you the same answer. N is equals to 5. Expected value you have find using this formula, right?
Yeah, 1.7 I got, sir, but answer is wrong. I mean, maybe calculation is wrong. I don't know.
Check your calculation because p should definitely be between 0 and 1, right?
Yeah.
So
No,
check
I'm getting P as 0.35, sir.
P as
0.35.
okay.
My expected value is 1.78. Maybe that is wrong. I don't know.
Okay, have you tried to solve it on Excel?
No, sir.
Okay, try it over Excel, right? And let me know.
Okay, sir. Okay, sir. You know that you when easier method is there, why you have to worry about E of xi, no, sir? Not required.
Yeah, but it's still good to try out different methods. There's no harm.
Okay. 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 Thank you, sir. I will do that.
Yes, sir. What is this one? Q?
Q is 1 minus P.
1 minus P.
Okay.
Okay.
So 1, 4, 5. Okay. 5 also, sir. One more this thing, sir. 5.
Yeah.
This is actually 4 C3 we have to do now, sir.
No. It is
Triple
asked,
S.
you should get S, S, Fs in this order only. So getting S at first position, its probability is P, right? Then S.
Okay. Okay. Not three is a success.
No. It you should.
Success, failure, success is only one.
Yeah.
Oh. Okay.
Okay. Moving further, distribution of binomial. Okay. So any doubt in it?
Sir,
Yeah.
sir, here also first question.
First question.
So
Okay.
the last question, sir.
It says E of, okay, afterwards I found out. N into you have to do. Last, fourth one, sir.
Question number 5.
One fourth option. Okay, I thought E of x is P, but after that I thought it is NP now.
Yeah. N is
N
not equal to
and
N.
N into P into 1 minus 1.
Yeah. And
So I got it, sir, later on. Okay, sorry.
5. Question number 5.
So the last one, sir.
okay. So
What's
how
this one?
to approach this one?
Sir, I took 0.45 as P, 0.045, and since it was percentage, I took N as 100.
Okay.
And 12th person is 4 C 0. I mean, xi.
Why 4 C?
P of 12 I took, sir. X is 12. P of x equal to 12.
Okay. So you are saying you took N as 100 and then you computed P of x is equals to 12, right?
Yes, sir.
So it means P of x equal to 12 means getting
12th person.
12 successes in 100 trials, right?
Oh. Okay.
So that won't be that way. Okay. So here let's say your success is that someone owns a crater, right? So and you know their chances are 4.5% only, right? Which is nothing but 0.045, right?
Yes, sir.
And you want to find out that the 12th one, like if I rephrase it, your 12th trial is second success, right?
Yes.
It means in
N
the,
equal to 12.
Yes, sir.
in the first 11 trial, you should have got only one success, right?
Okay.
And then in the 12th trial, you should get success, right?
Yes.
Plus success. Okay. So what are the chances of getting one success in 11 trials? It's 11C1, P raised to the power 1, and you need to get 10 failures, right? That's, you get it from Bernoulli distribution, right? But now in the 12th trial, you also need one success, right? So that's the success for 12th trial.
Sir, what is that brown P, sir? 12th trial P?
In 12th trial, you should get a success, right? Because
Okay.
you're getting second success in 12th trial. It means in the first 11 trials, you got only one success, which is this Bernoulli distribution, right? And then you also need to take into account that you are getting a success in 12th trial also.
Yeah. Probability of success is small p.
Yeah, that is 0.045, right?
Okay.
Is it clear?
So, sir, basically we need to break it down and then calculate.
Yeah.
In two cases over there. Oh, that's what I made wrong. Okay, sir, got it, sir. I actually calculated all together. Like first, then the rest of the 10, and then another case. So I took 12C2. That's why.
Yeah, 12C2 means you are getting 2 success in any of the 12 trial, right? But here it means you are getting second success in the
Yes,
12
sir. Yes.
trial only. So that's the difference. Okay, next.
So this binomial distribution formula is similar to what we have used in our earlier permutations and combinations and probability concepts, right?
Yeah.
Yeah, without the name itself, we were introduced, right? So all the same 11C, 0 and all the same concepts we are using here, right? Or any difference?
No, it's the same. See, week 9 to 12 is same as whatever you studied earlier. It's just we are doing it in terms of random variables and all that.
Yes, sir. Okay.
Okay, moving further to fourth lecture, modeling situation. Okay, so any doubt in this lecture or in this week, anyone? Have you solved it?
No, up to
Yes, sir. Yes, sir. No
five
doubt
only.
in this lecture.
So this one I took n as 4 and the probability as 0.01.
Probability at point. Okay.
0.1, sorry, 0.1.
Okay.
For C0, 0.1 to the power of 0, 0.9 to the power of 4. That is how I did, sir, first question. But not.
Okay, in first question, you need to find the value of n, right? So n is 4, you are saying, okay. Probabilities you are taking as 0.1, right? Okay. Then
And only one is defective. First, n
One.
in this it will be 4cx 0.1.
0.1 to the power x.
X 0.9.
Yeah,
that is. Yeah.
Okay.
That too.
Is it similar to any other option here?
Yes, the third option, sir. Third or fourth option.
Fourth, right? Because 4cx is same as 4c4.
Yeah, fourth option.
Okay.
This up to 3 correct, sir. Fourth question.
Fourth question, okay.
Probably translate message is wrong.
When there is
at least one bit error is wrong when there is at least one bit of error. So if more than one also it error only. So I found it for 0, which is no error will be there. Then subtracted from 1. So that will be the error even minimum 1. Correct, no, sir? That way?
Yeah, that's the correct way to approach. Because if you find for 1, 2, 3, and 4, that would be a lengthy process, even though you will get the same answer. But yeah, easiest way is to 1 minus that you got no error.
So that will be 4c0 into 0.1 to the power of 0, 0.9 to the power of 4.
Yeah.
Total minus 1 by this one.
Yeah.
Will be the answer.
Yeah.
Okay, that one correct, sir. Next one, sir.
Okay.
This I have not got the answer, sir.
Okay, an error can be recovered if the number of bits is less than or equal to 1. Okay, if we either correct or can be recovered. It means, okay, what it is saying is, if you got only one error in these 4 bits, you can still recover it. Okay, so what are the chances that you will either send the correct one or the one you sent can be recovered? It means either you have made no error or there was only one error, right? Because if there is only one error, you can recover. Let me just.
It's like p less than equals to 1 we need to calculate.
Yeah. So if you got 0 error, it means you have sent the correct one. If it's 1, it can be recovered, right? And for other values which are greater than 1, it's incorrect, right?
Yeah.
So you need to find out that the message you sent is either correct or can be recovered, right? Which means either x is equals to 0 or x is equals to
1. Yeah. 0.6561 is 0. 0.2916 is x1. So it will be 0.94. Correct, sir. I got it. I got that, sir.
Great. Okay. Any of these last two?
Sir, I did only up to this, sir. After this, I did not do. And
Okay.
And lecture, I went only up to hypergeometric, lecture 6. After that, I have not gone, sir. We have to go. today.
Okay. So when do you guys solve activity question? Is it just after watching the lecture, or you go through lectures first and then come back to questions?
Sir, after watching the lectures.
Immediately after watching the lecture, we do
Yes, sir.
corresponding.
Each lecture, sir.
I do each lecture, sir.
Yes, yeah, each lecture, sir. Like after watching one lecture, then corresponding that activity.
Okay. Great. Okay. So anyone and any other 7.4 or any further? Okay.
Sir, do we get later on the solution of this activity question?
Activity questions are purely based on lecture videos. Expect you to solve on your own or it on forums or in the sessions. The solutions won't be released for activity questions. Okay, yeah. So 11.5 expectation and variance of binomial random variable. Any doubt in this? Anyone?
No, sir.
No, sir. For me, it's like there is no doubt.
Okay, moving further. What about 11.6?
Sir,
Sir,
in
even
hypergeometric concept distribution, in concept, I have a doubt. In one lecture, ma'am has shown the curves of both hypergeometric and binomial distributions overlapping.
Yeah.
Like in the same graph, both were plotted together, right?
Yeah. Mhm.
In that, which one has more variability? Actually, binomial will have more variability, right? Like hyper will have lower variability, right?
Okay, yeah, because hypergeometric
The curve which is steeper is said to have less variability. Am I correct?
curve which is cheaper, yeah.
Steeper in the sense which is less in width.
Yeah, less than width, yeah.
Okay. So the hypergeometric curve will be the one with lower, because there was some confusion in my understanding when ma'am was explaining. So I just wanted to clear that. Okay.
Okay, so that curve part, is it clear or you have doubt in that?
It's clear now, sir.
Okay.
And otherwise, if you can take 2 minutes and explain once again, then also it is good. Like especially for the parts where small n and capital N are increasing, having n is less than n. So that part actually.
Okay. Yes.
11.7, question number 4, sir. Variance. Hello.
Yeah. Yes, I will go through that.
Green apple and red apple. That one.
Before that, do you recall what is the formula for hypergeometric distribution?
Bx.
But if your x is hypergeometric,
Yes. Bx is equal to n m by n into n minus m divided by n minus n into upon n minus 1.
by n into n minus n upon n minus 1, right? Okay. So
Yes.
if you look at it carefully,
Yes.
let's say we keep n as it is, right?
Right. N is equal to 500 apple.
No.
Okay. We are going from forward. Okay.
So small m by capital N, let's say it's P.
Okay.
Right?
Yes.
M is definitely less than equal to capital N, right? So
Correct.
be
Less than 1.
your P is gonna be in between 0 to 1 again, right?
Hmm.
This part, can I write it as 1 minus P?
Correct.
Right? And then I have this, right, in different color. I have this extra term, right? N minus n times n minus 1, right?
Right.
Okay. So, and if you recall your variance of binomial
is this NP1 minus P.
Yeah, NP1 minus P, right?
Correct.
So if you, okay, see the difference. So you have this extra term, right?
Right.
And this extra term is less than equal to 1 for sure, right?
Correct.
So it means in general your variance of hypergeometric,
Is equal, almost equal. Binomial. Right.
right? So now if your capital N is very large, right? Greater than, it means it's very large, right? So in that case, what would happen is the numerator and denominator would be very close, right?
Correct.
Very close means they could approximately be equal to 1, right? So in that case, your variance of hypergeometric would approximately be the same, right? So that would be that, and you can see it, you can visualize it through plots, right? It becomes more or less the same only, right?
Yeah, that we have seen. But by means of data which is given, we have to find it out. The answer is something different.
Just 11
Can you see that? 11.7, question number 4.
question number 4, okay.
Yes, this.
Okay, so make a
Answer, I think 4.96 I believe. Green. I
without-
just made a total April 500. So I think our capital N is 500.
right.
Then M given is 5, which we have to find it, take from green apple, which is given 250.
Okay, so small m is 250, right?
No, small n, small n is 250 and small m is equal to 5.
Right,
Right?
right.
I have applied the whole actually by taking care of last term also. So
Okay. Let's do it.
let me, I think that will be removed, then can be calculated.
Okay, so let's say
And
n equals to 5, right? M is equal
right,
to 250, right? Capital N is equals to 500, right?
right.
If I plug it in formula, your variance is n times. Okay, I just find P first. So your P is m by n, right? It becomes 250 by 500, which is 1 by
1
2.
by 2.
1 by 2. Then your 1 minus P would be again 1 by 2, right?
Correct.
Then capital N minus small n would be 495 over 490.
5499.
And almost 1.
It's 1.25 times some term which is very close to 1, right?
Correct.
So like we always give range in the answer, so it would definitely be in between
1.25. Okay, okay.
Instead of computing this value, you can directly plug in 1.25 also.
Okay, thank you, sir.
Okay, okay. Moving further. Any doubt in Poisson distribution?
Sir, it's better if you can give overview of Poisson distribution plus the expectation and variance. I know the expectation and variance is same, but it's better if you help us to derive and understand.
Okay.
Yeah.
We'll just
So second question in activity 11.8 Poisson distribution was also a little confusing.
okay, okay. I will go through Poisson distribution explanation first, then we will move to that.
Okay. Sir.
Okay, so Poisson distribution. Okay, so I will begin with an example first. Okay. 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 Suppose you on a website, let's say, okay, which sells some, let's say, goods, right? So based, like, you have some past data about people purchasing from your website, right? Let's say you know that average sales per day is 30. Okay. And you want to know what is the probability that you will have 4 sales in next 1 hour. How would you find it? So for that, you first need to find this, what is your probability of success, right? If you are going by binomial approach, right? For binomial, you need to know what is your n and what is your p, right?
Yes,
So-
sir.
Okay. So
For
I should-
this,
Hmm.
yeah, for this, since they are asking for 1 hour and average is given for per day. So this 30 is for 24 hours. And from that, we will calculate what is the value for 1 hour. What is the average for 1 hour?
Okay, so 30 per day means you will have some thing.
For 24 hours, it is 30. For 1 hour, what is the average?
It would be 1.25 per hour, right? 1.25 sales per hour, right?
Yeah, yeah.
Okay. But you need, it's like you are having 1.25 sales per hour, right? Okay. So, and this is your average, right? Average means your expected value, right? Which is n times p, if you are using binomial distribution, right? So it means if you are talking in terms of r, your n times p should be 1.25, right? But we
No,
can,
no, this 1.25 we will take as lambda.
okay. So 1.25.
Like this is for 1 hour, sir. We need to calculate the lambda for 4 hours.
Why? Okay, so it means you are
Sir,
gonna have
this is for
1.25 sales.
sir. This lambda is hourly, right?
This
Yeah,
this lambda we can use an e power minus lambda into lambda power 4 by, so that factorial with that formula we can put this, right?
Okay, let's forget about lambda for a minute. Let's say we want to find it using binomial distribution now.
Okay.
So we are focusing on finding n and p firstly, right? So you could have 1.25 sales per hour, right? As an average, it means your expected value is 1.25 per hour, right?
Yes, sir.
Okay, but someone can also take it in terms of minutes, right? It's possible that you could have 0.020 sales per minute, right? That's also, if you convert from day to hour and then to minutes, it will come out to be this, right? But it's also possible that you can have 2 sales in 1 second also, right? It's online website. It's possible that you get 4 sales in that second, right? In that case, your n times p would be something different, right?
Yes.
What's happening over here is, if you are taking per hour, right, it means your n is equals to 1, right? If you're talking about hour, 60, n is equals to 60, but you're going down and down, right? It's also possible that you could have in some fraction of seconds, you could have 2 sales, right? That's also possible. So here, if you notice that your n is going very large, right? And probability of success is going to very close to 0, right? Are you getting?
Yes, sir.
Yes, sir.
So, but we say in that case, we say, okay, this NP, let's say it's lambda. Okay, n times p is lambda. Okay, and we know this expected value, right? Now our main motive is to find that I will get some 4 sales in next 1 hour, right? So okay, so what we are doing is, okay, so let me just make some space over here. Okay, so what we have to find is, we need to find that I get some X sales, right? When my N is tends to infinity, right? So I will have to do it that way. NCX P raised to the power X, 1 minus P raised to the power N minus X, right? If I open it, it would be N factorial by X factorial N minus X factorial, P to the power X, 1 minus P raised to the power N minus X, right? Now recall, we are saying that our average is equal to lambda, right? It means my P is nothing but lambda over N, right? Is it clear till this step?
Yes, sir. Yes, sir. Yes, sir.
Okay. Now, if I open it a bit more, it would be N factorial by X factorial N minus X factorial. If I plug in the value of P, it would be lambda by N raised to the power X, right? 1 minus lambda by N raised to the power N minus X, right? Okay.
Yes, sir.
Okay. So N fact, if you notice this term carefully, right? Let's say this term, N factorial upon N minus X factorial. So I can open this term, right? So I will get in numerator, I will get this, right? And then N minus X factorial gets cancelled out. I will have X factorial in denominator, right? I have this lambda raised to the power X. In denominator, I have N raised to the power X, right? And this term, right?
Yes, sir.
Okay. So moving to next step, how many terms would be these? And like, this is my first term, this is second term. How many terms in total I would have? Anyone?
N minus X plus 1.
This N, my first term is N, second term is N minus 1. This term would be which term? Like third term is N minus 2, right?
Oh,
N
okay.
minus X plus 1 would be
X terms.
X.
X.
X. Okay.
I have X terms, right?
So it will be X factorial.
No, not X factorial. I have X terms. X factorial is 1 into 2 into 3 into up to X, right? It's not that. So, and in denominator, I also have nx, right? And raised to the power X means multiplying n x times, right?
Yes, X times.
So if I divide each of this term by n by this, right? I can write n raised to the power X separately, multiplying n x times, right? And then divide with each of these terms. So first term would be n by n, right? Second would be 1 minus 1 by n, 1 minus 2 by n, so on 1 minus x minus 1 by n.
Minus 1.
Did you get this step?
So last step, can you explain?
Okay.
Yes, yes, sir. Sir, I got it. Yes.
My first term is n, right?
Yeah, N upon N.
N upon n. Second
Yes.
term is n minus 1. N minus 1 upon n.
1, yeah, 1 minus 1 by N.
Similarly, third term, and similarly x term will also be divided by n, because I have
Yeah, got it. Yes.
right?
Yeah, yeah.
Remaining terms would be the same, right? It's x factorial as it is. It's lambda raised to over x as it is. And I have this 1 minus lambda over n, n minus x. Okay. So n by n is 1, right? Okay. And if you recall, your n tends to infinity, means n is very large, right? So 1 over very large term would be approximately 0, right?
Yes, sir. That will tend to 0.
Okay, and 2 over n will also be 0. I mean, any finite value divided by some large number would always be approximately 0, right? So this term will also be approximately 0, right? So in numerator, what you got is you got just 1 times 1 times 1 for this, right?
Yes, sir.
Denominator, you have x factorial. You have this lambda raised to the power x. Let me just write. Can I write this term as, can I split this term into these two? Can we do that? Hold
Yes,
it
sir.
to-
Minus, yes, to the power minus x, yes.
If you recall that this n is infinity, right? So this term will also be 0, right? 1 minus 0.
Yes,
At
sir.
1 minus 1 raised to the power anything would be just 1, right?
Yes,
One.
sir.
Yes, sir.
So this term also becomes 1, right?
Yes, sir.
So now what you are left with, lambda raised to the power x upon x factorial, and you have this n tending to infinity, 1 minus lambda by n raised to the power minus x, right?
Yes, sir.
So by using a mathematical property, this is the expression for e raised to the power minus lambda. So probability of getting x successes would be lambda raised to the power x, x factorial times e raised to the minus lambda. And this is what we called as PMF of Poisson distribution. So if you noticed carefully here, your Poisson distribution is nothing but binomial distribution only, in which your number of trials are very large. Probability of success in each of these trials is very low, right? And you don't know these values, you only know their product. You know the expected value only. So in such cases, we can directly use that. Poisson distribution is, it's nothing different, nothing new. It's same as binomial distribution, but since we don't know the exact value of n and exact value of p, right? So that's, but we know the average value. So using that, we have converted it into some new formulation and we named it as Poisson distribution. Is it clear or any doubt in this, anyone?
Clear, sir.
Clear, sir. Thank you.
Clear, sir.
Okay, what is the expected value of binomial distribution?
NP
NP.
1
N into P, sir.
And in Poisson, what happens is we know n tends to infinity, p tends to 0, but n times p is equals to lambda, right?
Yes,
Yeah.
sir.
So for Poisson, it would be just lambda, right? And what about variance of binomial distribution? It's n times
NP 1 minus P.
1
1
minus.
minus p.
Okay, so np is just lambda, right?
Yes, sir.
And p is nothing but 1 over lambda by n, right?
Yes, sir.
But we know that n is very large. It means
So lambda.
lambda by infinity would be close to 0, right?
0,
Yes.
yes.
So this
That's
term
why
would be 1 minus 0,
1 minus 0.
1. So variance of x is also
Lambda.
Yeah.
lambda, right? So
Variance and x.
it is same as binomial distribution with these two conditions. Okay. Any doubt in Poisson distribution questions, anyone?
So second question.
Second question, okay. The text denotes a number of radioactive particles passing through a counter in 1 millisecond time interval, okay.
So that is counted and uncounted. There is some confusion. Like what is the for 1 millisecond? It is asking for. I mean, it has given the number of particles, and then probability is given for counted.
Okay.
And again, the parameter was also given. Lambda is equal to 3. And the number of particles counted was asked in the probability. So again, why they have taken the reverse probability, like 1 minus p they have taken. I didn't understand why they have taken.
Okay, I will just write it down. The number of particles passing will not be counted as 0.01. Okay. Was counted during the specific time interval is 3. Okay, so we'll call this H. Okay, so here, let's say we are interested in number of particles not counted, right?
Counted, sir. Probability of number of particles counted during specific time interval.
Counted. Okay. Number of particles passing. Okay, it's counted, right? The probability that number of particle passing will not be counted is 0.01. Okay. So let's say probability, it's not counted is 0.01. Okay. Okay. Then assuming that X follows a Poisson distribution with lambda equals 3. Okay. Lambda equals 3. Okay. It means your n times p in binomial distribution is 3, right? And find the probability that number of particles counted during a specific time interval is 3. Okay. Wait. Okay, so we know lambda is equals to 3, which is same as n times p, right?
Yes, sir.
Okay, find the probability that number of particles counted during a specific time interval is 3. A particle. Okay. Okay, I think this second line should be that probability that a particle is not counted as 0.01 instead of complete. Okay. I think it should be that. This second.
It is even then. No, I understood as not counted. They have given 0.01. So
Okay.
for the probability for counted will be 0.99, right?
Yeah, in that case it would be
0.99. So for taking the lambda, even though they have given straightforward as lambda is equal to 3, instead of using that e power minus 3, they have somehow multiplied this 3 with the 0.99. E power minus 2.97 they have used. This 2.97 comes only when they multiply 0.99 with 3. I didn't understand why there was a need to multiply both of them. Lambda was given straight away, right? And that lambda is for x itself. So
right. 0.99. Yeah, it should be 3 only, right? It should be 3. It should not be 2.97.
Yeah, for x itself that lambda is given, right? So e power minus 3 into 3 power 3 by 3 factorial. It should be.
I think in that case, the second line is just.
Second line is an unnecessary information, maybe.
Yeah, it should be e minus 3. Yeah.
Okay. And that does that 1 millisecond time interval also make any impact?
No, it won't. It's just showing you that 1 millisecond. You can still break it down. Okay, if you take 1 millisecond as one trial, right? But you can still break it down into smaller and smaller fractions, right?
Okay.
N will tends to infinity and P will tend. Okay. That's the main point. Okay. Any other question? Okay. Anyone? Anything else in week 11? Okay, any other doubt?
Sir, I haven't attempted last two, so cannot ask.
Okay, so we do have one more session for week 11, right?
Okay. So when?
It's on Saturday, right? The deadline is till Sunday, so you will have solved with the session.
Okay. Sir, I wanted to ask one more thing. Sir, is it possible to have frequent classes, frequent doubt sessions next week so that we can ask the questions from week 1 to like whatever we wanted to ask? Because
Mhm.
I wanted to ask many questions from the earlier weeks.
Okay, so are you in the Telegram group of on-demand sessions?
No, actually, I am into Telegram. Sometimes I have seen like only 2 times the message pop up for the on-demand session, out
Mm,
of which one time nobody was there inside.
Okay, so we will schedule more on-demand sessions, right? So we will,
Okay.
so in those on-demand sessions, you can come and ask your doubts. So we will make it like focus on some specific weeks, right? So initially it will be week 1 to 4, then 5 to 8, then so on.
So
Depend.
again, this on-demand sessions, if they are on Google Meet, we are not able to join. It is asking for someone to let
Yeah,
us in.
they will let you in. They will let you in. Just wait and they will let you in. On-demand
Yeah.
session, basically your senior, those who have cleared stats 1 with good grades. So those 2 students, I think those who attended might know Rohan and Arunima. They will handle it. You can have some discussion with them as a senior and ask them for your doubts. They will do it.
Okay, sir.
Okay, so yeah, be active on a Telegram group. We will send you, like we will schedule, I think, sessions all day in from tomorrow onwards. We will do on demand.
Okay, sir.
And any suitable timings for any one of you, or do the evening times work for all?
Sir, I think the evening time is the best time.
Okay, we will keep it.
Yeah.
Okay. Anything else? Anyone? Or shall we close for today? Okay, I think we will close for. Okay, thank